Alrighty, it is time for a change of attire, as it is only like 20 degrees right now in this cold Midwest morning. But my time has finally come. For you see, let me tell you a brief little story, and I promise this won't take up too much of your time. So, I, me, my favorite dinosaurs are oviraptors. All kinds of oviraptors. Whether it is, Gigantoraptor, which was huge, to Oviraptor itself, which is not so huge. Anyway, today we're talking about oviraptors and their nesting habits, as new studies have come out about them. And as they're my favorite dinosaur, I'm going to want to talk about them. So this is an article that I found on Sci News. I don't think they were the original publisher of the article, but it's still kind of interesting, and I'm really, really happy for this one. This was published about a week ago-ish, sort of, and it has to do with the fact that oviraptors kind of need the sun. They need sunny D, unleash the power of the sun, in order to hatch their eggs, potentially. This is a pretty fun one, honestly. So, yeah, we're going to talk about it a little bit. I will show you the article, and it's great. It's going to be fun. I promise you. I promise. I promise. Bear with me here. So, yeah, let's dive into it. I don't think this one's going to be nearly as long as the cigarette bird video. It's still funny to me. It shouldn't be. It's kind of sad, but it's still funny to me. Alrighty. Here we are. Sci News. This article was posted March 17th, 2026. So, yeah, not super far back. Like I said, I'm not entirely sure that this was where it was published initially. I think it was published someplace else. I've not read this whole thing. I've read it in bits and pieces, but it's an interesting article. So, let's get into it. Oviraptors may have needed the sun to hatch their eggs. New experiments indicate bird-like oviraptor dinosaurs could not fully warm their eggs with body heat alone, instead combining brooding with solar warmth in semi-open nests. This actually would make sense, because the way we found, their nests, they're, in, a circular pattern. So, that might have something to do with the sun, maybe? By the way, this art is wonderful. I love this. The Oviraptor is essentially a turkey here. The art is by Sheng Zhao. I hope I'm not saying their name wrong, and if I am, I apologize. We show the difference in oviraptor hatching patterns was induced by the relative position of the incubating adult to the eggs, says Dr. Zhu Rui Yang, a paleontologist at Taiwan's National Museum of Natural Science. Moreover, we obtained an estimate of the incubation efficiency of oviraptors, which is much lower than that of modern birds. In the study, the researchers simulated the brooding behavior of, I'm gonna really butcher this. We'll just say oviraptors, because Hey, you on the Hungai? I'm saying that wrong. Surely. Anyway, a species of oviraptor dinosaur that lived in what today is China during the late Cretaceous epoch, about 70 to 66 million years ago. Estimated to be around 1.5 meters long and weighing around 20 kilograms. It built semi-open nests made up of several rings of eggs. That's what I meant by the circle thing. The incubating Oviraptor's trunk was made from polyester foam and wood for the skeletal. Oh, so they tested this. That's interesting. They actually did a simulation. Wood for the skeletal frame and cotton, bubble paper, and cloth for the soft tissue. Eggs were molded from casting resin in the 2 clutches used in the experiments. Eggs were arranged in double rings based on real Oviraptor clutches, so the nests that they found. Part of the difficulty lies in reconstructing Oviraptor incubation realistically, Sue said. For example, their eggs are unlike those of any living species, so we invented the resin eggs to approximate real Oviraptor eggs as best as we could. And here's more wonderful art. I see this picture a lot, actually, when Oviraptors come up. This picture comes up quite a bit. When the team ran experiments to find out if clutch attendance of a brooding adult or different environmental circumstances may have impacted hatching patterns, they found that in colder temperatures, where a brooding adult attended the clutch, the egg temperatures in the outer ring differed by up to 6 degrees Celsius, which could have resulted in asynchronous hatching, a pattern where eggs in the same nest hatch at different times. In warmer conditions, the difference in egg temperatures in the outer ring was just 0.6 degrees Celsius, suggesting that Oviraptors living in warmer conditions may have exhibited a different pattern of asynchronous hatching because they could use the sun as an additional powerful heat source. It's unlikely that large dinosaurs sat atop their clutches. Supposedly, they used the heat of the sun or soil to hatch their eggs, like turtles. Since Oviraptor clutches are open to the air, heat from the sun likely mattered much more than heat from the soil. The researchers also investigated how Oviraptor incubation efficiency compares to that of modern birds. Most birds use thermal regulatory contact incubation, where adults sit directly on the eggs to transfer heat. The thermal regulation contact incubation requires 3 prerequisites. The adult bird must be in contact with every egg by the main heat source, and maintain all eggs within a constrained temperature range, which Oviraptors didn't fulfill, according to their experiment. Oviraptors may not have been able to conduct the thermal regulatory contact incubation as modern birds do. Instead, these dinosaurs and the sun may have been co-incubators, a less efficient incubation behavior than that displayed by modern birds. Yet the combination of adult incubation and an ambient heat source, perhaps a behavioral adaptation associated with the evolution from buried to semi-open nests, isn't necessarily worse. Modern birds aren't better at hatching eggs. Instead, birds living today and Oviraptors have a very different way of incubation, or more specifically, brooding. Nothing is better or worse. It just depends on the environment. So, what they're saying in this article is that they tested, apparently, they ran a simulation on how the incubation for Oviraptor eggs might have worked. And based on their findings, they found that they may have potentially had to have used the sun to help incubate their eggs. This is very fascinating to me. Very interesting. I love Oviraptors. Have I mentioned that before? They're great. They're so great. If you follow me, you know that they're my favorite dinosaurs. So yeah, this is kind of just a fun article about a test that they conducted, and I'm very curious to see how it kind of translates to other dinosaurs. Because some dinosaurs, like the article said, are just too big to brood. And I know that that's kind of been an interesting topic with paleontologists on how larger dinosaurs would have done it. I know some people have suggested that sauropods didn't they just laid the nest, buried it, and then left and let the ambient environment do the work. And And then I've also seen like in the dinosaurs documentary with like the Maiasaura, where they oh I'm sorry, the hadrosaurs as they called them, because they never say what the hadrosaurs in the dinosaurs Netflix documentary actually were, but they definitely were implied to at least be Maiasaura or at least Edmontosaurus. So, but anyway, they show them like nesting in like these large like groups where they're like protecting each other's nests. So that's another thing that's been thrown around. But like we don't really know 100%. We just make hypothesis based on like information we do know and also studying modern birds. So this is kind of just a fun one, I think. There's a lot to be learned through like the nesting behaviors of different animals, because it tells you if they were a caring parent, if they were not a caring parent, if they let the environment do the work, or in this case, they kind of did a mix of both where they used the sun and also traditional brooding to hatch the eggs, to help incubate them. And so we kind of, because these are these open air nests, potentially they could have been doing this sort of back and forth mix of methods that just kind of makes this a little bit more interesting, I think. We don't really know for sure, but it's a pretty fun like experiment, and I like that they like tested this, like they actually like built a mold of like the nests based on like real Oviraptor nests that have been found, and they actually like gave it a test run to see like if it worked. So kind of fun, kind of interesting, and I kind of want to like know more when if more information about this comes out, or if they do more tests. I kind of would like to be up to date with this seems like a really fun experiment. I think this is ongoing. I'm not 100% sure. The article doesn't really say, but I saw other sources, and they made it sound like it was an ongoing like experiment. Like they weren't done. They were doing more. So I would also like to see if this is just specifically this one species of Oviraptor, or if it's like across the board with the entire group. Because as we see in like modern birds, different birds have different nesting methods. So I wonder if Oviraptors would be potentially the same way, or if it was kind of like a universal like adaptation to just use the sun. So, yeah. Anyway, that's all I really have to talk about here with this article. I think it's pretty cool. Oviraptors are still my favorite dinosaurs, and yeah, I think this is pretty great. And bye-bye for now. Unless we see something else. I know there was a new dinosaur discovered in Korea this week, I believe, or last week, like the end of last week, I think, that was announced. So we're probably gonna have to talk about that. But yeah, there was other things too. There was like stuff to do with like shells, like different species of like clams and stuff, and like prehistoric clams, and there was like other stuff. But we'll see what we can get to this week. Who knows? I kind of ditched the podcast format and decided just to focus on individual stories at the moment. We'll see if the podcast format comes back, but for now I kind of just like the idea of just picking an article and talking about it. I think that's a bit more interesting. Plus I can get more like videos out easier and faster. The only downside to like recording a podcast is like it's time consuming, and this is more like straightforward. I can just be like, hey, this is a cool thing that's going on in paleontology or other sciences or other things that I think might be interesting and fun for the channel. So yeah, maybe like, maybe subscribe, maybe you know, comment. Tell me what you think. But yeah, no, I would really like to see if this is if other Oviraptor like species do this as well. That'd be really cool to find out.